Okay, the very last trend that we're going to look at in these notes is electronegativity, and the definition of this is how attracted an atom is to a bonding pair of electrons. Now we measure this on a relative scale. The scale basically goes from 0 to 4. And we call this the Pauling scale, invented by Linus Pauling. As we go down a group, our electronegativity decreases. So as we go down a group, the attraction that my elements have is less. And as we go across a period, my attraction is more. Let's talk about why. So down a group first. As we go down a group, as we saw in atomic radius, my atomic radius increases. So I have a bigger space between, so there's more distance between my inner protons and my valence electrons. So more distance between protons and outermost electrons. Because my radius is increasing, it means that these protons have less attraction to those outermost electrons. So again, these protons, because they're so far away, they experience less attraction to the outermost electrons. So less attraction between the protons and the outermost electrons. Because there's less attraction, it also means less attraction between the protons and the bonding pair of electrons. So again, as we go down the group, our atoms get bigger and bigger. And so the distance between my protons and electrons is much greater. And so being able to attract an electron at this size is much easier because here we're much closer versus cesium, where we have a much larger distance to try to attract a bonding pair of electrons. Okay? Across a period is quite similar, so let's write that here. Okay, across a period. So as we saw in the atomic radius trend, as we go across a period, the distance between the center protons and outer electrons decreases. So we have a smaller atomic radius, which means there's less distance between my innermost protons and my valence electrons, which means that there's more attraction between those protons and electrons. So my protons are better able to attract those electrons, which means a greater attraction between the protons and a bonding pair of electrons. Between protons and bonding pair of electrons. Okay, and that's electronegativity. So once again, we use the Pauling scale to determine the electronegativity. As we go down a group, because my protons are so far away from any bonding electrons, there's very little attraction. So our electronegativity is very low. As we go across a period, we get more and more protons with the same number of shielding electrons. So our effective nuclear charge increases, our radius decreases, and there's more attraction available from the inner protons in the nucleus to that bonding pair of electrons.